Okay, guys, this is Jerry, your former maths teacher, coming back to you with some online stuff as well to beat the virus. So hopefully you stay with me on this. Hang on, let me see if I can zoom in here. Oh, that's not good. Okay, that's better. Is that better? Yeah. And what I want to talk to you today about is the matrices stuff, the matrix multiplication. Remember, we talked about this on Monday. On the first day, we said that matrix addition and subtraction is fine, but really the action in matrix land occurs with multiplying matrices together. And there are two main types of multiplication that you have to do. So the first multiplication that you have to do is square by square, which gives you another square. We'll do some examples in a minute. So that's the first type of multiplication that you're going to have to do. So a square would be a 2 by 2 or a 3 by 3 or a 4 by 4. And similarly here, this square matrix has to have the same dimension as the other one, of course, before you get multiplication. So this is a 2 by 2, you get a 2 by 2. And if this is a 3 by 3, you get a 3 by 3. You get the picture. The other type of matrix multiplication is when you're multiplying a square matrix multiplied by a vector. And when you do that, you get a vector. And that's really important as well. So there's the two main types of matrix multiplication. Okay, so I'll do a few examples here. Now it's much harder here in terms of dimensions here because the dimensions for vectors and squares are not identical. So I'll just do a few examples and show you how easy this is. Well, how easy it could be once you've practiced this. Now, at the end of the session, this is the first part of the lecture. I'm going to stop and I'm going to ask you to look at the examples or the questions that I've posted up online on Loop. And you should do those questions before you go on to part 2, because it's really important that you practice this. That's it. It's just practice this. That's all this stuff is. Okay. Now, whenever you're multiplying matrices together, the number one rule, the rule that you have to apply is this. You're multiplying rows by columns. Sorry, that's just to get columns. So you should be multiplying here. So you're going to be multiplying rows by columns to get other columns. Again, this is the column here of the product matrix. So I know I'm making this an awful bags of this, and it sounds a lot more complicated than it is, but it isn't that actually complicated. So what I'm going to do first now is I'm going to do some examples. Then, as I say, I'm going to stop, and then you must practice this stuff. Okay. So the first example here we're going to look at is matrix A. Let's call it 2, 0, 1, 1. And suppose we have a matrix B, and it's 1, 3, minus 1, 1. Okay, and what we're going to do now is we're going to multiply A by B. So what you should do whenever you get asked to do multiplication, matrix multiplication, is you should write the matrices down. So A is 2, 0, here's 1, 1. And B then is 1, 3, minus 1, 1. Whenever you do matrix multiplication, just underneath it or somewhere close by, write down the dimensions, 2 by 2. And these two here are the same, so we can multiply. We talked about this on the first lecture. And so what you should be getting is the two outer numbers. So what we're going to get here is we're going to get a 2 by 2 matrix. And when you first start doing matrix multiplication, it's probably very important to actually, put little lines here in the product matrix to show what you want to get. Okay. So what we're going to do now is we're going to multiply rows by columns to get columns. So to get the first column of the product matrix, you need to multiply the rows by the first column of the second matrix. So what I'm going to do now first is I'm going to look at this column first, and I'm going to multiply each row of the first matrix by that column. So the first one here is 2 by 1 plus 0 by minus 1. Okay, so you're going to multiply rows by columns. Okay, so again, rows by columns on this entry down here is 1 plus 1 plus 1 by minus 1. Okay, so to get the first column of the product matrix, you need to multiply the rows of the first matrix by the first column of the second matrix. Okay, now there is a reason why matrix multiplication is as daft or as seemingly complicated as it is. And we'll see this when we start talking about simultaneous equations. But for the moment, I just want you to try and see if just get these rules into your head. Okay, to get the second column of the product matrix, what you need to do now is you need to focus on this column, okay? And again, now I'm going to multiply rows by the second column to get the second column of the product matrix. So it's 2 by 3 plus 0 by 1. And the next one then is 1 by 3 plus 1 by 1. Okay, so hopefully I haven't made a mistake there. If I make a mistake when I'm doing this, you need to email me and tell me I made a mistake, but don't. All right. So then finally, when you do the addition here, it's 2 by 1, which is 2, plus 0, which is 2, 1 plus minus 1, which is 0, 3 plus 1, which are 3 plus 0, which are 6 plus 0, which is 6, and then 3 plus 1, which is 4. And if you want to, you can leave it as this, that's fine. But because you've got a common factor here of 2 in each of the entries here, you can bring the 2 outside if you want to. You don't have to, and you can have 1, 3, 0, 2. But you don't have to do that. That's really optional. And we've talked about this in the first lecture about who could do this. So you know who you are. Okay, so now we've multiplied A by B. I want now try to do is multiply B by A. Okay, so let me just do that. So BA then is, you write down B, you write down A. So BA is 1, 3, minus 1, 1, and A is 2, 0, 1, 1. And so what I'm going to get here then is this. So again here, got the thing. So you're going to look at, to get the first column here, you're going to look at the first column here. So it's 1 by 2 plus 3 by 1. 1 by 2 plus 3 by 1. The next one then is minus 1 by 2 plus 1 by 1. And that gives you the first column of the product matrix. To get the second column of the product matrix, because this is a 2 by 2, and this is a 2 by 2, so you're going to get a 2 by 2 matrix here. To get the second column, you're going to look at the second column of the second matrix and multiply again by rows. So rows by columns gives you columns. So 1 by 0, which is 0, plus 3 by 1 here. And then minus 1 by 0, plus 1 by 1. And so when you do the multiplication there, you get 1 plus 2, which is 5. You get 0 here. You get minus 1 here. And I can't read my writing here, so you get 1 here, I think. That's minus 1 by 0 and 1 by 1, so you get 1 here. Now, what you should notice here, folks, is very important in the matrix multiplication, is that therefore AB is not equal to BA. So this is BA here. And if you recall the first one there, you got AB, which was 2604, and you see there that they're just not the same. Okay, so that's very important. So AB is not equal to BA. And that is something that's very counterintuitive, because in ordinary multiplication, it is what's called commutative in mathematics, because A by B is equal to B by A in ordinary mathematics, in ordinary multiplication. But in matrix multiplication, it isn't. Do not forget this. This is really important, and it crops up a lot. And so therefore, you must be very, very careful. Okay, so that's multiplying 2 square matrices together. Let me go on and do another one here. I'm going to multiply a square matrix by a square matrix by a vector. So I'm going to, let me do one example where it doesn't work, and another example where it does. So let me set that A equal to be 1, 3, 0, 1, 1, 1, and then 0, 0, minus 1. And let B, now usually when you're talking about a vector matrix, which is either a column or a row, you use lowercase letters. Now you don't have to, but I'm going to use that as the convention. So let me just do that. So in this case, let me write down 2 or 3 vectors here. Let me write down B, and the first vector is 1, 0, 1. Let me write down another one then, which is C. Right, there's a theme here. Let me write that down as 1, 0. And the last one then we call it D. Let me write that down as minus 1, 0, 1, just taking as the examples. So these are 3 examples of vectors. One is a row vector and the other 2 are column vectors. So I'm going to try and multiply A by each of those. So if you look at AB first, so the dimensions of AB here, folks, are, this is a 3 by 3. This is a 1 by 3. And as you see here, folks, the 3 and the 1 are not the same, so you cannot do AB. So that's really important. Now, in practice, when you encounter these in engineering analysis, this rarely is a problem, but it could be a problem in the exam. So for instance, so I might just just for the sheer hell of it, give you two matrices that you can't multiply, and you have to tell me that you can't multiply them and show me how clever you are. All right. If you try and multiply AC, this is a 3 by 3, and this is a 2 by 1. Again, these two numbers here are not the same. You can multiply A by C. But if you look at AD, this is a 3 by 3, and D is a 3 by 1, and you can do it because these two numbers are the same. And what you get when you multiply a square matrix by a vector column is you get another column. Okay, so let me just do that here. So you get 1, 3, 0, 1, 1, 1, 0, 0, minus 1, and you multiply that by minus 1, 0, 1. So here's what you get. Now remember matrix multiplication, you're multiplying rows by columns. Now in this case, there's only one column in the second matrix, so you're going to multiply each row of the first matrix by their column. Okay, so you get 1 by 3. No, it's not. It's 1 by minus 1. 1 by minus 1 plus 3 by 0 plus 0 by 1. Right? So 1 by minus 1, 3 by 0, and 0 by 0. Or 0 by 1, which is, yeah. And then the next one then is 1 by minus 1 plus 1 by 0 plus 1 by 1. And the last one then is 0 by minus 1, which is 0, 0 by 0 is 0, and you get minus 1 here at the bottom. So finally, when you do all that stupid calculation, you probably can't even see this because the marker is so bad. Stupid D3 marker. So what you get in the end here is you get 1 by minus 1, so you get minus 1 here. You get minus 1 plus 1 here, which is 0, I think. And the last one, you get minus 1. Okay? And if you want to bring the minus outside, you can write this as minus 1 into 1, 0, 1, if you want to, but this is fine. Okay? Now, that matrix multiplication, or that particular example here, is very, very important because this is typically what you see in engineering analysis. You're multiplying a square matrix by a column vector of the same dimension, by which I mean this is a 3 by 3, this is a 3 by 1. You can work it, and that's a very, very common multiplication. Okay, so you probably will see some of that in the exam, if nothing else. All right, last thing I'm going to do before I'll stop here and then you start working is just some stupid notation, which I just want to talk to you about. The other notation is this. There's some notation that you see frequently, and you need to get kind of happy with this. Is this kind of notation of a matrix with a square. And all that means is you multiply the matrix A by itself. Okay, now usually this notation here, when you talk about squares and cubes and to the power 4, you're talking about a square matrix, and it always makes sense. So usually when you're using, you have to have this notation. If you're using this notation, square, cubed, and to the power 4, A must be square. Now, I'm not going to give you a non-square matrix and ask you to do something squared because you can't do it. That's kind of stupid. And I wouldn't do that because I'm just too nice. Okay, but let me just show you what I mean. Here's an example, and there's some examples in exercises 1 on loop. So here's an example. So let me just do A is 1, 0, 0, minus 1, 2. What's A squared? Okay, so what you do is you multiply A by A. So here it is, minus 1 by 0. It's not, it's plus 1 by 0, and minus 1 by 2, by 1, 0, minus 1, 2. So again, rows by columns. So 1 by 1 plus 0 by minus 1. Minus 1 by 1 plus 2 by minus 1. Okay, so that gives me the first column by focusing on the first column of the second matrix. To get the next column, I'm going to focus on this one. So it's 1 by 0 plus 0 by 2 minus 1 by 0 plus 2 by 2. And when you do that calculation, folks, you'll get 1 plus minus 1, which is 0. You get 1, so you get 0 here. You get minus 1 plus minus 2, so that's minus 3. And you get minus 1 here plus 2, this is 4, and that's what you get. Okay, hopefully that's what you get. So there you are. That's a very, very important little notation. So you've got a square matrix, and if attached to the square matrix, you have this a square, it means you take the matrix and you multiply it by itself. That's all it means. And because you have the same matrix in your multiplication, it doesn't matter which one comes first because they're identical. A cubed means you multiply the matrix A by itself 3 times. A to the power 4, you multiply it by itself 4 times, and so on. And that gives you, and that's very important. So what we've done here is really, really important, and it's definitely examinable. You will see this as you go through your engineering careers, well, especially in education, at least anyway. So why not get on top of this? Now, as I say, on loop, there's what are called exercises 1. Okay? Open that up. There's about maybe 20 questions that you have to answer. The solutions are, not the solutions, the answers are given. So what you need to do is you need to do the calculation and make sure you get the right answer. And I'll email you about this. Maybe then if you have any problems, what we'll do is we'll set up a forum next week for those 2 or 3 of you who are actually watching this. And if you have any problems, then you can email me and I'll answer the most popular difficulties. Okay, I can't answer every single student because there's 160 students there. So what I'll do is I'll open up a forum maybe next week sometime, and if you have any issues, you email me there, and what I'll do then, as I say, is I'll do the, if the same problems are cropping up, I will do those problems, 2 or 3 problems, and put the solutions on loop. Okay, so that's what we're going to do. So yep, that's it, and I'm going to stop now. But you don't stop. This is where you come into your own. So you're now going to look at exercises 1 and you're going to do them all. All right, it's going to take you a while. It's going to take you maybe about an hour, but bloody well do it. All right, that's it. And I'll talk to you in the next lecture. All right, bye.